Okay, how do we arrange elements in the periodic table? Any table that we draw up will have rows and columns. This is a diagram to show us what each of these terms actually means. The columns are from up to down, so they are more or less vertical. Meanwhile, the rows are from side to side, otherwise they are horizontal. Okay. Now, we will not call in a periodic table, we will not say a column and a row, no. We have special words that are used to describe a column and a row when we're looking at the periodic table. So like we said in the previous slide, the groups and the periods will then represent the column and the rows respectively. So the groups, what we call groups in a periodic table, are the vertical columns of the periodic table. And these groups are numbered in such a way that group 1 is on the left. That's our group 1. It's on the left extreme of the periodic table. Similarly, the periods are the horizontal rows of the periodic table. And the first period is at the top, where we have hydrogen there. That's the first period. It's at the top of the periodic table. When we're looking at the groups are numbered from group 1 to group 18. It means there are 18 groups in the periodic table. And why do we put them in groups? Because elements that behave in a similar way will then be put in the same group. So if we identify two elements that behave similarly, then we will make sure that they are included in the same group. And why will they behave similarly? That will be just because they have the same or similar chemical properties. Hence, their behavior will be the same. Hence, we shall say, you belong to the same group, or you must belong to the same group. For example, such elements, for example, we can include potassium, sodium, and lithium, which are all members of group 1. And that is because they have similar chemical properties, hence they will react in a similar way. If, for example, you put a piece of potassium or sodium or lithium in water, it will react vigorously with water, producing some kind of hissing sound, and at the same time releasing gas while moving on the surface, like it's rushing from one side to another, moving around the surface of water. And at the end of the day, they will all form similar products because they behave more or less the same way. They will form similar products when they also react with oxygen. And physically, yes, they are solid, but they are all quite soft. They are soft and then can be cut just like with a bar of butter. They can be cut with a knife, as if you're cutting through a bar of butter. With the periods, we can count up to 7 periods in the periodic table. And remember, the periods go from left to right horizontally. And as we're moving from left to right within each period, the atomic numbers of the elements will be increased by 1 as we are moving from left to right across that period. So if we go down to a next period downwards, we can also move again left to right, and within that lower period, the atomic numbers will also increase by 1 as we move from left to right. It means the atoms of the elements in that period, as we move from left to right, they get an increment of 1, 1, 1 each time we're moving from one atom of an element to the next atom of another element. The atomic number keeps on increasing. It means the number of protons keep on increasing. That's what it basically means. Now we can then use groups and periods to allocate or to describe where an element, to pinpoint it, like we try to pinpoint something with a GPS. We can use groups and periods to pinpoint where an element is actually found in the periodic table. For example, if I want to pinpoint where calcium is, I will have to look into group 2, and into group 2 I'll be looking at period 4. If you go to group 2 period 4 of the periodic table, you must be able to find calcium there with that formula, Ca. So like we said before, if you go to group 2 period 4 of the periodic table, at the intercept of those two, you must be able to find calcium there. That is our calcium, group 2 period 4. Okay, calcium is there. Good. Now let's look at the classification of these elements, why we group them. The elements in the periodic table can be classified into 3 groups. Okay, 3 groups. We have the metals, the non-metals, and the semi-metals. Those are the 3 groups into which we can put elements on the periodic table. Now, we will see the metals are found mostly in the left region. The left region here. Mostly in the left region. That's where we'll find metals. The non-metals will be found mostly in the right-hand region, this side here. That's where we'll find non-metals, such that we will be left with a greenish step-like or jagged region here, where we have the semi-metals. Semi because they have some properties of metals, though they are not truly metals. They are halfway, and you can see even in their positioning here on the periodic table, it's made sure that they are halfway between metals and non-metals. So that's what you'll find here on the periodic table. Okay, if you look at the periodic table, you'll come to one realization. You'll notice that actually most of the elements in the periodic table, most of the elements are metals. You see, it's occupying more or less all the central and left-hand region of the periodic table. And what are some of the properties of metals? All the metals, all of them are solids. I'm sure we know what solids are from the 3 phases of matter. All the metals are solids at room temperature, normal ambient temperature, except for mercury with the symbol Hg. We'll find mercury there at group 12, period 6. Okay. Mercury is liquid at room temperature. You'll usually find mercury at the tip of our traditional thermometers, the olden ones before these electronic thermometers came to be. Now, metals, other properties, apart from just being solids. Yes, we said metals are solids at room temperature. They are typically hard. It's not easy to break. For example, iron, it is hard. Metals are also usually shiny or lustrous. The bling bling. Okay, that's why you like bling bling, because they are shiny, they are lustrous. They are malleable, almost like rubber. Okay, you can bend, you can squeeze here and there, and they are fusible, because if I heat up some metals, I can actually merge them, I can fuse them together after heating them up. And metals are also ductile. It means that they are able to be deformed. You can deform them without them losing their toughness. Okay. And metals have good electrical conductivity and thermal conductivity. That's why we refer to them as conductors. They are not insulators, because they can allow heat and electricity to pass through them from one point to another. So here you have some examples of metals like iron, gold, silver, aluminium, and alloys, also precursors such as steel. Okay, you have what metals look like here. If you want to get a clearer picture, that's more or less what your metals will look like. The non-metals are found, like we said earlier, on the right hand side of the periodic table. Okay, and they are mostly gases. The non-metals could have the three states: gas, solid, and liquid. They are mostly gases. A few of them are solids at room temperature, but with the exception of bromine, which is found at group 17, period 4. The exception of bromine, which has the symbol Br, which is a liquid at room temperature. So non-metals could either be gases at room temperature, solids at room temperature, or liquids, that would be bromine, at room temperature. So here we have the semi-metals. They are present in this zigzag green line here on either side of the zigzag line in the periodic table, or otherwise they are found between the metals and the non-metals. And like I said earlier, they are found in that position because they have properties of both metals and non-metals. It means they behave like metals or non-metals. Now, going back to our period, the periods of the periodic table. We said the periods are the rows. So I have 7 periods, like I said. 1, 2, 3, 4, and all of that. Okay. And they run from left to right horizontally. We then said that when we move within a period, the atomic number increases. So it means if I take, for example, period 4, if my atomic number started, say, with 19, I hope it's 19, then from there I'll have 20, 21, 22, 23, 24, 25. It means the atomic number is increasing by 1 each time up to the end there. If I go to period 5, let's say my atomic number here starts with 58. For example, I'm just saying, it will increase from 58, we'll go to 59, 60, 61, 62, 63, and so on and so forth. We go down here, let's say it starts with 88 or 89. We'll go to 90, 91, 92, 93, and so on and so forth. That's how the atomic number, or the number of protons, increases across the periods, or yes, across the elements that are found in or within a particular period. From 1, 1, 1, 1, it increased by a unit of 1 as we move from one element to another. And you also see that it means as we move from one group to another, the atomic number increases within the same period. That's what it means. I have included here a table that gives us the list of the first 20 elements of the periodic table. And in that table, we have the symbols of the elements, and we have the names of the elements together with the atomic numbers of the elements from 1 to 20. On the side here, I've included, I won't call it a song, some wordings that will help you to memorize the elements number 1 to 20 as they occur in order. And if you can give them in order, it also means that you can at each time know the atomic number of a particular element. For example, carbon there. If I have that list in my mind plain, I can pick out the atomic number of each element. This is useful in answering questions very quickly without having to refer to any place. Okay, it's good you know this. So I'm going to lead you through what we say so that you will memorize it. That's the way we were also taught. My story goes like, hey, he likes beating boys coming near our field. New nation magnifies. All silly people should clean our kitchen carefully. Hey, he likes beating boys coming near our field. New nation magnifies. All silly people should clean our kitchen carefully. So we go with it. Hey, I've highlighted some particular letters that will stand out as the symbols or the formulae of those elements. Hey, I've highlighted here only H. To say H stands for hydrogen, and my hydrogen is number 1. Atomic number is 1. He, I've highlighted H and E together. Stands for helium. Helium period, that's atomic number 2. That will be its atomic number because it has 2 protons. Remember, hydrogen had only 1 proton. That's why it was the lightest of all the elements. Likes. I've highlighted L and I for lithium. Atomic number 3. Beating. Beating, I've highlighted B and E for beryllium. Atomic number 4. Boys. Boys, I've highlighted only B for boron. Atomic number 5. Coming, I've highlighted only C. C for carbon. Atomic number 6. Near, I've highlighted N. N for nitrogen. Atomic number 7. Hour, I've highlighted O. O for oxygen. Atomic number 8. Field, I've highlighted only F. Atomic number, that's fluorine. Atomic number 9. New, I've highlighted N and E for neon. Atomic number 10. Nation, I've highlighted N and A for sodium. Atomic number 11. Magnifies. Here I use the word magnesium for magnifies. I've highlighted M and separately G for Mg. Magnesium. Atomic number 12. All I've highlighted A and L for aluminium. Atomic number 13. Silly, I've highlighted S and I for silicon. Atomic number 14. People, I've highlighted only P for phosphorus. Atomic number 15. Should, I've highlighted only S for sulfur. Atomic number 16. Clean, I've highlighted C and L for chlorine. Atomic number 17. R, I've highlighted A and R for argon. Atomic number 18. Kitchen, I've highlighted K only for potassium. Atomic number 20. And carefully, I've highlighted C and A for calcium. Atomic number 20. So that's how you can memorize the first 20 elements of the periodic table. Take note that some of them don't exactly reflect the kind of words we use. For example, R for argon, I just said, should clean our kitchen, as if I'm saying our kitchen. And magnesium, the letters are a bit separate, but gives us that symbol. So that's the first 20 elements of the periodic table. Memorize this. I have it always in my mind like that. Forever is going to be there in my mind.